We now take a look at our test application that uses the employee class hierarchy. In main of this application, you can see at lines 9 through 18 that we're creating objects of each of the 4 subclasses of class employee. We begin at lines 9 and 10 with a new salaried employee object for John Smith. At lines 11 and 12, we have a new hourly employee object for Karen Price. At lines 13 through 15, we have a new commission employee object for Sue Jones, and at lines 16 through 18, we have a new base plus commission employee object for Bob Lewis. And the thing to keep in mind with each of these constructor calls that results from the new operation is that each one calls the subclass constructor, then in turn calls its immediately preceding superclasses constructor. So for example, when we say new salaried employee, that results in a call to the salaried employee constructor, which in turn calls the employee constructor, which in turn calls the object constructor. And again, each constructor is responsible for initializing the parts of the salaried employee object that come from each independent level of the hierarchy. It's not that we're creating 3 separate objects here, it's that we're creating one object that has parts that came from 3 separate classes. And the same type of thing happens with hourly employee and commission employee. In the case of base plus commission employee, when that constructor gets called, it invokes the commission employee constructor, which in turn invokes the employee constructor, and then the object constructor. And again, that's because of the way that the hierarchy was put together. Class base plus commission employee has pieces that come from the class base plus commission employee, the class commission employee, the class employee, and the class object. So once we've created these 4 objects, and also so that we can check and see if the rest of the program works correctly, we go and we output the string representations and the earnings results for each of the 4 different employees. So in this highlighted chunk of code, we're going to output here on line 23 the string representation of the salaried employee object that's going to be placed in this %s specifier, and then we're going to show you what the employee earned, and we're going to output that by calling the employee's earnings method. So the salaried employee's earnings should return to us the fixed weekly salary for that employee, which is going to be $800 based on how we initialized the employee John Smith. And of course here we are outputting that with a %,.2f specifier. The comma indicates that if there are thousands of dollars, that the each thousands indicator will be separated with commas, and then separately the .2f is indicating that we are going to format the number with 2 digits to the right of the decimal point. And we do that for all of our dollar amounts. We also output the literal $sign as well. By the way, Java does have internationalization capabilities that would allow you to format things like dollar amounts or monetary figures using locale specific formatting. And what we mean by that is if you were running this same program, say in Europe, where they use the comma as the decimal point, and they use the decimal point as what we use for a comma, then in that case you would automatically get the switch over as you output this on a European computer. We're not using that formatting here. Instead, we're just hard coding our specific formatting for US dollars. We do the same thing for each of the different types of employees. So here at lines 24 and 25, we are going to output the string representation of the hourly employee and the hourly employee's earnings, which of course should be wages times hours worked, assuming that the hours worked is 40 or fewer. And if you look back at the employee Karen Price, you can see that the hours worked was 40 exactly. So we don't have to worry about overtime. We'll just multiply 40 times 16.75, and that'll give you your hourly employee's earnings. And then at lines 26 and 27, we're going to output the string representation of the commission employee and the commission employee's earnings, which will be the gross sales times the commission rate from back at line 15. And then finally, we're going to output the string representation of our base plus commission employee, and we're going to output the earnings of the base plus commission employee, which will be gross sales times commission rate, and then we'll add on the base salary as well. Now if we stop right there and go ahead and run this so we can look at the beginning of our output, we can take a look at each of the different employee outputs and make sure that in fact they were displayed correctly. So for example here's our salaried employee John Smith, and you can confirm by looking at the initializer values that are now highlighted at line 10 that the values output were indeed correct for John Smith. And similarly we have our hourly employee Karen Price, and again you can compare the values here with the values back at line 12 to make sure that we output the correct information. And for our commission employee Sue Jones, again take a look at line 15 now to make sure that the data here is identical to that of line 15. And then finally at the last piece here, the base salaried commission employee Bob Lewis, you can compare that data to what we show you on line 18. So the purpose of that part of the program is simply to show you that we're getting what we expect when we get the two-string representation and the earnings for each of the 4 different employee types. Now we move ahead to line 33 in the program, where we've declared and created a new array of 4 employee variables. And it's important to point out that when we say new employee in this case on line 33, we are not creating employee objects. Remember that an array of a non-primitive type in Java is going to create an array of variables that can hold references to objects of that type. So what we have here are 4 employee variables, all of which are pre-initialized to null for us, but we have not yet caused these variables to be aimed at specific types of employee objects. So again, 4 elements in the array. And at lines 36 through 39, we then populate the array 1 element at a time by assigning each element one of our variables: salaried employee, hourly employee, commission employee, and base plus commission employee. Now, at compile time, the compiler looks at an expression like line 36 and checks to see if the type of the variable on the right matches the type of the variable on the left. Well, based on the declaration of the array employees, we know that this variable on the left represents 1 employee variable, and an employee variable can hold a reference to anything that is an employee. Well, a salaried employee is an employee, and as we go from the right side of the assignment to the left side of the assignment, as long as we are going up the class hierarchy to a superclass type, then we are allowed to do the assignment. So because a salaried employee is an employee, this is an allowed assignment. And the same thing is true with each of these subsequent assignments. An hourly employee is an employee, a commission employee is an employee, and a base plus commission employee is an employee. And in one way you can look at this array as a homogeneous set of employee variables. Every one of them is a variable of type employee. But you can also look at this array as a heterogeneous set of objects, in that we have 4 different types of employees that are actually populating the array. 1 salaried employee, 1 hourly employee, 1 commission employee, and 1 base plus commission employee. And here's where we can now try to take advantage of this polymorphic processing capability, in that we can create a piece of code that just cares about the fact that we're looking at employees, and then we can process each of those employees doing the things that are common for all employees. And we do that with this loop here at lines 44 through 65. First of all, you'll notice that the loop itself doesn't say anything in its header about salaried employees, hourly employees, commission employees, or base plus commission employees. It says basically for each employee, which we'll call current employee, in the array employees, that we'd like to do 2 key things. At line 46, we'd like to print the string representation of the current employee. And at line 63 and 64, we'd like to print the earnings of the current employee. Now, we'll come back to the if statement in the middle in a moment here, but let's talk about line 46. We know that when we output any object as a string, its toString method is going to get called. So this is the same thing as if we had put a .toString to the right of the word current employee. And what we're doing here is saying invoke the toString method of whatever object I happen to be looking at and output that object. And because toString can be done for any object, including employees, we are indeed able to output the current employee as a string representation. Down here at line 64, when you look at the highlighted expression, the only type name that the compiler knows about in line 64 is the type of the variable current employee. There are no objects as far as the compiler is concerned. So all it can do is look at this expression and say, what's the type of current employee? According to this declaration at line 44, it is an employee. And then the compiler can go look at class employee and say, does class employee have an earnings method that takes no parameters and returns a value that we could then use for output purposes here. And if you go back to class employee, you can recall that we had in class employee the earnings method. It is an abstract method, but it says that every class that is a derivative of employee must have an earnings method that takes no parameters and returns a value, in this case of type double. So you may say, well, wait a second, that's an abstract method. How can the compiler look at the statement back here in main, or the expression back here in main, and say that you're allowed to call earnings if that method is abstract? Well, think about it. The variable current employee at runtime has to point to something that is a subtype of employee because we can't create employee objects directly. So at runtime, I know that this variable is either null, in which case we're going to get a null pointer exception when we try to call the method, and we'll talk about exceptions in a subsequent lesson, or it has to be pointing to something that is an employee. And we made a big deal as we went through the employee class hierarchy of how every single one of those subclasses of employee hard codes an actual implementation of the earnings method. So by signing the contract with the compiler when you extend class employee and implementing the earnings method in each of those classes, we are guaranteeing that by the time this expression executes at runtime, the current employee variable will be pointing to something that is an employee and therefore is guaranteed to have an earnings method. And that's the key thing with polymorphism. As long as every one of the classes in the hierarchy has that method, I can take this superclass reference, aim it at any subclass object, and then call earnings, and I know with 100% certainty that the proper earnings method will be called for whatever the type of the employee is at runtime. Now, we did do one thing special in this loop. At lines 49 through 61, we have some code that is going to do some specific processing for any object of type BasePlusCommissionEmployee. Now, before we get to that code in detail, first I'd like to take a look at part of the output again, specifically in the part that prints out employees processed polymorphically. These first three parts, we can confirm that everything that was output is correct for the salaried employee, the hourly employee, and the commission employee. So if you look at these three chunks of output and you go back up to the beginning of our program's output and compare them with these three chunks, you'll see that indeed all of the string representations are identical and all of the earnings method calculations are identical as well. However, when we get to the base salaried commission employee, the final output is a little bit different because of this nested if statement in our polymorphic for loop. So if you take a look at line 49 in particular, we're introducing a new operator, the instance of operator. You might also call that the is-a operator. What we're asking is whether or not the thing that current employee is referring to is an instance of the class on the right side of the operator. So if the object that current employee refers to is a BasePlusCommissionEmployee, and when I say is a, I mean specifically a BasePlusCommissionEmployee or any object of a class that inherits from BasePlusCommissionEmployee, this condition will be true. In that case, we will go into line 53 through 60, and we're going to do some base plus commission employee specific functionality. So if you take a look at lines 53 and 54, the base plus commission employee variable called employee is being declared on line 53. And in line 54, we are casting the superclass variable current employee, which is of type employee, down to the subclass type base plus commission employee. This is what we call a downcast operation, and what it's going to do is it's going to give us the ability to aim the employee variable of type base plus commission employee at the subclass base plus commission employee object, so that we can then call base plus commission employee specific functionality. Now, this cast operator in Java can fail at runtime if whatever current employee is pointing to is not a base plus commission employee. However, the condition that we've wrapped around this chunk of code explicitly tests to make sure that we're looking at a base plus commission employee before we're allowed to do this cast operator. So this condition is actually protecting this cast operation, making sure that it really will work at runtime. And then once we get to line 56, we're now processing a base plus commission employee object. And in this example, what we want to do is, if the particular employee is a base plus commission employee, we're going to give them a 10% base salary raise, and then we'll calculate their earnings based on that raise. So you can see here at line 56, we're using the base plus commission employee variable called employee, and we're calling a base plus commission employee specific method get base salary. We can't call that through the commission employee variable, the current employee variable, because current employee is of type employee, and class employee does not have a get base salary method. So given that, we had to use a base plus commission employee variable, which is why we did this cast operation back at lines 53 and 54. So we take the base salary and store it in this variable old base salary. We then set the employee's base salary to 1.1 times the old base salary, which raises it by 10%. And then at lines 58 through 60, we print out what the base plus commission employee's new base salary is with a 10% increase. Notice, by the way, if you want to output a percent sign, you need to use two of them in a row, because percent signs are special in the first string inside of a printf. So we then get the new base salary for our base plus commission employee, and then by the time we get to line 63 to calculate the current employee's earnings, the base salary has been increased by 10%. So let's go back up to the top here and look at how we initialized our base plus commission employee. The original base salary was $300. So let's keep that in mind as we now go look at our program's output. And you can see when we originally output the base salaried commission employee's earnings, it was $500, and that was based on 5,000 times a commission rate of 0.04, which gave us $200, plus a base salary of $300. Now, when we went and did the polymorphic processing and eventually got down to playing with the base salaried commission employee object, at that point the base salary was still $300, but then we increased it by 10% to make it $330. So when we add $330 to 5,000 times 0.04, so $330 plus $200 gives us a earnings calculation of $530. So you can see that we did indeed do the 10% increase of the base salary by using this nested if statement that is specific to anything that is a base plus commission employee. So you can envision, for example, in a company payroll system where you're walking through looking for all employees of a specific type and being able to process all those employees of that specific subtype and give them a 10% raise. That's basically what we've done here, is said anybody who's a base plus commission employee should get a 10% raise. And since we only had one employee of that type in the array, only one employee got the raise. We do have one last bit in this example before we finish up, and that's this last for loop here at lines 68 through 70. You may recall when we first gave you the overview of class object that we talked about the fact that every object knows its own type at runtime, and the way an object can determine its own type is by calling its getClass method, which is inherited directly or indirectly from class object. So what we're doing now is we're walking through the employees array one element at a time, and we're saying to each individual subclass of employee object, get your class, and this actually returns an object of the class that is named class with a capital C. And one of that class's methods is getName, which returns the name of the class. And all we wanted to do here was show you that we really do know the type of every object at runtime. So if you look at the very end of our output here, you can see that employee 0 is a salaried employee, employee 1 is an hourly employee, employee 2 is a commission employee, and employee 3 is a base plus commission employee. And if you compare that with the way we initialize the elements of the array, you can see that indeed it printed out the types of the employees in the exact same order that we used to initialize the array. So now that we've been through this example, we've seen the key functionality, which was our ability to do some type-specific programming at the beginning of main here, where what we really wanted to do was create our objects. Then we had some type generic programming where we placed all of those objects into an array of type employee and then polymorphically processed every one of the elements in that array by getting the string representation of each one and by calculating the earnings of each one as well. In our next example, we're going to look at another way to do polymorphism using a concept called interfaces.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.